Last episode, the gradient stopped, ignoring the rare class. Scale pause weight tilted the ransomware beacon detector toward the 1.5% of traffic that was actually an attack, and recall jumped. But here's the uncomfortable follow up. How do you even know a detector is good? Most teams reach for the one number everyone trusts: accuracy. So let me show you the most dangerous model in this whole course. It does nothing. It calls every single connection benign and it scores 80% accuracy. On some malware feeds, a do nothing model hits 97%. If accuracy is your headline, you just shipped a detector that catches 0 attacks and looks great in the deck. The misconception this episode kills: high accuracy means a good detector. We bring back the episode 2 phishing dataset, seed 42, the house data, where 20% of URLs are phishing and 80% are benign. Now we build a model with one rule: always predict benign. It is right on every benign URL and wrong on every phishing URL. 80% right. The bar chart shows it, a fat 0.80 accuracy bar sitting next to a real XGBoost at 0.96, only 16 points apart, which makes the do nothing model look like it's nearly competitive. It is not. It catches nothing. Why does accuracy lie? Because on imbalanced data, accuracy is dominated by the majority class. We draw the confusion grid for the all benign model. The benign column is fully green, the phishing column is fully red. Every attack missed. Accuracy counts those green benign cells and drowns the red. The number it reports is the prevalence of the easy class, not the skill of the detector. The visual that kills it: a 0.80 accuracy badge pinned to a grid with a recall of exactly 0. So what do we measure instead? Precision and recall, the two numbers a SOC actually lives by. Precision: of the alerts you raised, how many were real attacks, your false positive pain? Recall: of all the real attacks, how many you caught, your miss rate? The all benign model raises 0 alerts, so its recall is 0. It is invisible to accuracy but obvious to recall. We show two dials, precision and recall, the do nothing model, pegging recall at 0.0 while accuracy still glows 0.80. Now collapse precision and recall into one honest headline: PROC, the area under the precision recall curve. Its floor isn't 0.5 like a coin flip, it's the prevalence. A random or useless model on this data scores PRAUC VAV 0, 10, 20 because about 20% of the URLs are positive. That flat dashed line at 0.20 is the you have learned nothing baseline. XGBoost arcs up to 0.958. The gap between 0.958 and the 0.20 floor, not the gap between 0.96 and 0.80 accuracy, is the real measure of skill. This is why we report the security honest set every episode. PRAUC, precision, recall, and FPR at a chosen threshold. Never accuracy alone. Accuracy gets exactly one appearance in this whole course, and it's right here as the suspect. The takeaway pins to screen: on imbalanced security data, always compare your metric to its no skill floor. Accuracy's floor is the majority fraction. PRAUC's floor is prevalence. Beat the floor or you've shipped nothing. Open Zo4 PR AOS not accuracy.py. Same seed 42 phishing data as episode 2. Identical numbers, the house dataset, plus one deliberately useless model for contrast. We rebuild the episode 2 world, make classification with weights ordo 8, 0.2. So phishing is 20% of traffic. Then rename the columns to real lexical host features: URL length, num dots as HTTPs, subdomain count, entropy, age days, fixed random state 42, stratified split. This is byte identical to the house detector you will see again in episodes 12, 13, and 15. We define the villain in 2 lines: dummy classifier, strategy, most frequent. No training signal, no features, It learns that benign is the majority and predicts it for everyone. This is the just look at accuracy trap made concrete. We train the real XGBoost, modest depth, the same honest knobs, and pull predict proba for the phishing class from both models. The dummy's probability is a flat constant, the benign rate, which is exactly why its PR curve will be a flat line. Now the reveal, accuracy score and average precision score, that's PR AUC for both. The dummy prints ARC SOD 80, PR AUC 0203, XGBoost prints AUC 0 to 96, PR AUC 0 9 58. Accuracy says they're close. PR AUC says one is a detector and one is furniture. We plot both precision recall curves with precision recall display, draw the prevalence floor as a dashed amber rule at 0.20, and annotate each curve with its accuracy so the lie is visible in one frame. High accuracy flat curve. So burn this in. Accuracy is the number that flatters useless models on rare attack data. Measure PRAUC against prevalence instead. Next episode, SECO5, we point the honest metrics at a real anti-malware task, a PE header classifier, and read which structural signals XGBoost actually leans on to separate malware from benign.